So this is the pulley problem. We've got 32 kilograms here, 5 kilograms there. We're told that to drag this guy along the plane at a constant speed, that the force of friction on this guy is 34.5. So if this thing is sliding that way, as it certainly will as soon as we release this thing, if it's sliding that way, then the 34.5 newtons is going to be this way. So we're just given that as that's the force of friction. But back in the day, we could calculate that from the mass of that and something called the coefficient of friction. But we're not doing that. Okay. Now we've got this problem, right? We got 5 kilograms there, 32 kilograms here, right? And this is the deal. Oh, before we start, right? This string is massless string. Because if it had mass, this problem is much more sophisticated. As in, the more string that's hanging over the edge, the faster it accelerates, right? Okay, so we're not going to go there. This pulley is frictionless and massless. We'll cover all the bases there. There is a chapter in the book where they talk about rotational mechanics and where this thing has mass and it rotates. But that makes it much more difficult, and we're not going to go there. So what that means is that whatever tension is in this string, whatever that tension is, it's the same. It's the same here as it is here. Now, if I put my finger on this thing and stop it from moving, I hold that. What is the tension in that string? What does it have to be to prevent the 5 kilogram block from falling? It has to be 49.05. That's exactly correct. If the system is not accelerating, the tension in that string is 49.05, and he got that by going 5 times 9.81. That's the weight of 5 kilograms, correct? Are we good so far? Yes. Now, if I do release it, we know that that force is bigger than this force, so it must accelerate, yes? Do we all agree on that? But now we've got a problem. It's not a big problem, but it's a little problem, okay? If it's accelerating, the tension is definitely less than 49.05. How do I know that? Well, I'll tell you how I know it. This thing's accelerating down, and when masses accelerate down, the tension in the string holding them is less than their weight, correct? So therefore, that tension depends on the acceleration, doesn't it? Yes. Tension depends on the acceleration. The faster it accelerates, the less tension there is, correct? Okay, now we've got another problem. If I wanted to find the acceleration would be, well, without the string, 9.81 straight down, but with the string, something less, correct? So therefore, the acceleration, in turn, depends on the tension, doesn't it? So acceleration depends on tension, tension depends on acceleration, and it's well, it must be able to be solved, right? I mean, for every combination of these masses and these forces, there would be a particular acceleration and no other acceleration. I think we all have that intuition, right? It must be able to be solved, but this whole thing about tension depending on acceleration and acceleration depending on tension, all that means is that we have a system of equations. We're going to have 2 equations. We've got to solve them simultaneously, right? And the good news is that we can solve these by simple linear combination. Every time, if it's a massless frictionless pulley, you'll see what I mean. And it's the simplest linear combination there is. We can just add the equations and a variable drops out and we're almost done, right? So let me show you how to solve these things. Step by step, the first thing you do, okay, step number 1 is to calculate and label the forces. Okay, so I'm going to calculate the force of gravity acting on this guy. Okay, there's going to be a downward force. This is going to be 5 times 9.81, and it's going to be 49.05. Okay, another force, and it's going to be a smaller force than 49.05, will be the tension. Okay, so I'm going to draw a line up, and it's going to be shorter than this line. So let's draw it like that. Okay, isn't the tension going to act up? That's crazy. Which way does the tension on the string act on this block? The tension is going to push the block to the left? Strings have a real hard time pushing. Yeah, it's actually going to pull it to the right. So the same force here is going to act here. So that's weird. This is a weird thing. We're not used to strings, but let's at least acknowledge this, right? Okay. If I throw the string to you, and you hold onto the other end and you pull, okay, we're pulling on the string. I feel pulled toward Bobby, and Bobby feels pulled toward me. That's the way strings work. They pull in equal and opposite directions. Are these equal and opposite forces? Yes, they are. You can let go now. All right. He's like, I will not let go until specifically instructed to let go. Okay, now, then I need to label, I'm going to make the 34.5 newtons smaller than the tension, okay? Because I know that must be the pecking order. Isn't the tension bigger than the 34.5 newtons? Because that thing's accelerating that way, right? And isn't 49.05 bigger than the tension because that one's accelerating down, right? Yes, sir? Oh, because it's a friction force and this block is moving to the right, friction always acts opposite the direction you're moving, right? Now, step number 2 that must always be followed is that you have to decide, you have to make the acceleration, okay, make the acceleration positive. The next step is make the acceleration positive. The direction of the acceleration, make it positive. Because you can't make two equations and have the same acceleration positive in one and negative in another, because then they're different accelerations. Okay? So I'm going to make, what that means is that I'm going to make positive this direction, and I'm going to make positive this direction. Okay? That the acceleration is going to be positive down and this way. So I'm literally making 49.05 positive, right? Make all the, what are the things that the protagonists, make them positive, and all the antagonists make them negative for the literary minded, yes? So in this case, for this acceleration, this is the protagonist, antagonist, protagonist, antagonist, yes? Does that make sense? Right? And now the final step is that we're going to do, we're going to set up two F equals ma equations, set up two F equals ma equations, and then just solve. So we're almost done with physics, but not quite. Okay? So for the 5 kilogram mass, okay, this is the positive one. This guy's a positive force. This guy's a negative force. For this guy, this is a positive force. This guy's a negative force. Right? Okay, so for the 5 kilogram guy, we've got 49.05. That's the protagonist, the thing causing the acceleration, minus the thing preventing or reducing the acceleration, right? That equals 5 times A. Yeah? So for the 5 kilogram mass, that's the equation. For the 32 kilogram mass, the equation is the thing causing the acceleration. So that's T, minus the thing preventing the acceleration. That's this guy, the 34.5, equals 32A. Now, that's two equations, two unknowns. How hard can that be? That could be very hard, right? No, it's not actually so hard. We could do this. There are 3 ways to solve these. One is substitution. We solve the top equation for T, plug that in there and solve for A. That's a pain in the butt. If you can avoid substitution, do so. The second way is that we can do a linear combination where we multiply these by different things, add them together to make variables drop out, right? In this case, we can actually just add them together. And the third way is, of course, matrices. These things, though, it is always the case for these things, since the tension in one is always negative and in the other positive, and if it's not, you've set it up wrong, okay? Right, so it's always causing one thing to accelerate. It's always preventing another thing from accelerating as fast as it might, right? Okay, so it's always the case that we can just add these together. T will drop out, right? So we get 49.05 plus T minus T, no T at all, right? 34.5. That's a little bit sad, right? And then 5A plus 32A is 37A, right? And then A ultimately equals 49. And there's a certain beauty to this solution. Do you see in that solution that basically it's all the forces causing the acceleration minus all the forces preventing the acceleration divided by the sum of the mass? Do you see that? They're all like that. Every single one is like that. Right? So I solved so many of these apparently in the course of getting a physics major that I could just go right to this equation. I could just look at a problem and just go right to that equation. I don't recommend it. I'm certain that somebody could write a problem confusing enough